Okay, so before this, in 6.3, we did some work with square root functions. You know, we graphed them and we talked about their domain and range and saw what they looked like in a coordinate system when you're dealing with functions of x and of y. So what we're going to be doing today is we're going to be simplifying radicals. So we're still going to be talking about square roots. We're going to be simplifying some of them, but we're actually going to move past square roots into what we call nth roots. So cubed roots and fourth roots and other roots like that. So the ideas are very similar to square roots, but we're kind of expanding upon the stuff that we already know. All right, so key concept here. All right, the definition of an nth root. So nth could be, you know, second, third, fourth, fifth, etc. The definition means it's the inverse. The inverse of raising a number to the nth power. Okay, the inverse meaning like what one function does, the other one does the opposite. So squaring a function or squaring a number is the inverse of square rooting a number, or taking the square root. So the third root, for instance, would be the inverse of cubing something, and the fourth root would be the inverse of raising something to the fourth power. So they undo what that original power does. So the definition here, for any real numbers a and b and any positive integer n, here's what we start off with. If a to the n equals b, so if you know that relationship is true. For example, we know that 3 to the fourth equals 81. We've got that. All right, so then if we do the nth root, then we know that the nth root of b would give you a. Okay, so they kind of do these opposite things. So if you raise something to the nth power and you get b, that means when you take the nth root of b, you get back to a. So this means that the fourth root of 81 gives you 3. Okay, so if you're trying to take a fourth root or a third root or any other type of root, with square roots you're trying to find out what multiplies by itself twice to give me this number. With a fourth root, you're trying to figure out what multiplies by itself 4 times in order to give me 81, and that would be 3. So that's just one particular example here. Let me show you guys what the notation looks like. So you have an nth root, and then you put something underneath the radical sign here. And I just want to label a couple of things on here. Okay, so this thing right here, for instance, we call it, whatever this number is, we call it the index. So I'll be talking about the index, so just so you're aware of what that is. If there isn't one written there, it's 2. So like the second root, you just write the radical sign. You don't put a little 2 in there. Speaking of the radical sign, that's what this actual weird bar-looking thing is. So I'm going to talk about the radical sign. That's this piece right here. And then whatever's underneath the radical sign, we call that a radicand, which I mentioned in the notes yesterday. It's a stupid sounding word, but that's what it is. Okay, so just some notation there. All right, the principal root is like, the principal, think of it as like the main root. So that's the non-negative roots. When n is even. Okay, so if you're taking square roots or you're taking fourth roots, there are always technically going to be 2 answers, a positive and a negative. If you're taking a cube root, you only have 1 answer. So that's what I mean by if n is even. We'll see more specific examples of that. Okay, so the real nth roots, we're going to give you every possibility right here. So if a is greater than 0, less than 0, equal to 0, and that's whatever is underneath the square root, and then n is the index. Okay, so we've got 2 different categories. Either n is even, so like I said, 2 or 4 or whatever, or if n is odd, so 3, 5, etc. Okay, so say, for instance, we've got a is greater than 0 and n is even. Okay, what you end up with is 1 positive and 1 negative root. We're going to say real roots, because they are, in fact, real numbers. All right, so for instance, the one that I gave you up above, if you take the fourth root of 81. So here you've got a positive number as the radicand, and you've got an even index. So we technically end up with plus or minus 3. It could be positive 3 or it could be negative 3. Because if you take negative 3 and raise it to the fourth power, you also get 81. Okay, so now let's say that n is odd. If n is odd, you end up with 1 positive real roots. Okay, so that again is if you've got a positive number underneath the radical sign and if your index is odd. So for instance, the cubed root of 27, meaning what multiplies by itself 3 times and gives you 27, and that would be positive 3. So just the one answer there. You don't do plus or minus because negative 3 cubed actually is not positive 27, it's negative 27, but we'll get down there right about here. Okay, if you've got a negative number underneath the square root, then you get 0 real roots. They would end up being imaginary. All right, so say I asked you to take the square root of negative 9. So this is technically an even index because it's really a 2, and you've got a negative number underneath. You don't get anything real. You get an imaginary number. All right, and it doesn't really matter if it's plus or minus because the whole point is that we don't have any real roots, they're only imaginary. Okay, say I had a negative under and I had an odd root. Then you get 1 negative real root. So let's just switch this one up to a negative 27. Say I took the cube root of a negative 27. Similar question, what multiplies by itself 3 times to give me negative 27? And that would actually be negative 3. Because negative 3 times negative 3 times negative 3, if I do it 3 times, it still comes back negative. Okay, so I can take the cube root of a negative. Just can't take the second root or the fourth root or anything like that. Okay, if a is 0, you get 1 real root and it's 0. Okay, so if I had you take like the fourth root of 0 or the square root of 0, it's like what multiplies by itself to give you 0? Well, the answer has to be 0. Same thing if n is odd. You still get that 1 real root of 0. So say I could do even a 5th root or like an 11th root, it doesn't matter. You're going to get 0 no matter what. Okay? All right, so this is just to kind of keep in the back of your mind knowing what kind of answers you should be expecting. Let's look at some of these examples and we can start to simplify some things up. Okay, so now depending on what you've got going on the outside, here you have a plus or minus, so they want both of the answers. Here they have a negative on the outside, so they only want the negative answer. Here there's not anything on the outside, so they want the principal root, whatever it is. And then here, we'll deal with this one in a second because it's got a negative. All right, so this one, we know my answer is going to be plus or minus. I have a square root. So when you're taking square roots, you're thinking, okay, what multiplies by itself to give me this? Okay, so what multiplies by itself to give me 36? And that would be 6, because 6 times 6 is 36. And then for x to the 10th, same question. What multiplies by itself to give me x to the 10th? And that would be x to the 5th. All right, x to the 5th times x to the 5th gives you 10 total copies of x, or x to the 10th. Okay, so 6x to the 5th. You can always kind of check your answer. So let me show you what I mean. You can take 6x to the 5th and square it, and you should get right back to this. It's like 6 squared is 36, and then if you do x to the 5th squared, you multiply the 5 times 2, and you get 10. So quick little trick for you. See how here I multiplied 5 times 2 to get 10? Here you can divide 10 by 2 and get 5. Just a little trick for you. Okay, this one. Since I have a negative on the outside, I make my answer negative. And now here it's like what multiplies by itself to give me y plus 7 to the 16th. Now think of the trick that I just did here. Here my index is 2, technically, and so I took 10 divided by 2 to give me 5. Here, my index is again 2, because I'm taking a square root, so I can do 16 divided by 2 to give me 8. Okay, so if I multiply that by itself, I get y plus 7 to the 16th. Because if I square this, I would do 8 times 2, and that gives me a new power of 16. Okay, next one, 5th root. 5th roots are a little bit interesting. They're not anything that we've really had much experience with before. So this one, the 5th root of 243. It's like, all right, what multiplies by itself 5 times to give me 243? Okay, what I want to do is, I'm just going to show you guys on the calculator. We're going to play around with a couple of numbers here. Okay, so it's got to be low, because if you multiply something by itself 5 times, it's going to get huge. I mean, picture even 10. If you multiply 10 by itself 5 times, you get 100,000. So the fact that 243 is pretty low compared to 100,000 means it's going to be a pretty low number. All right, so I'll show you guys really quickly one thing that we could do. So we could take like 2, for instance. We're like, oh, I wonder if it's 2. First of all, it's not, because 243 is odd. But just to show you, 2 to the 5th gives you 32. So we check the next one. 3 to the 5th. There it is, 243. All right, so since 3 to the 5th gives us 243, that means the 5th root of 243 is 3. Now, since we're taking a 5th root, it's definitely not plus or minus. We just do the principal root, which is just kind of whatever comes out. Because negative 3 would not be an answer. If I took negative 3 and raised it to the 5th power, I would actually get negative 243. Okay, so now a to the 10th. What multiplies by itself 5 times to give me a to the 10th? Here's the quick trick that I showed you up here. The index is 5. This power is 10. Just do 10 divided by 5. And you get a power of 2. Okay, and then same thing with this. B to the 15th. What multiplies by itself 5 times to give me b to the 15th? Divide 15 by 5. You get b to the 3rd. So picture multiplying this out 5 times. 3 5 times gives me 243. If I did a squared 5 times, a squared times a squared times a squared times a squared times a squared, I would get a to the 10th. And same thing with b cubed. If I multiplied that out 5 times, I would get b to the 15th. All right? And last one here. The square root of negative 4. I don't get any real roots because there's a negative under a even index because the index is 2. So I just write 2i. Okay, that's my imaginary answer. Okay, so not terrible so far. Let's take a look at the other stuff that we've got here. Okay, this is just a quick note here, and it's going to seem a little tricky, but I'll walk you guys through it. When you find an even root of an even power, okay, so if the index is even and the power inside is even, just like what's happening here. Here the index is 2 and the power is 6. They're both even. And the result is an odd power. You must use the absolute value to ensure the answer is non-negative. Okay, so I realize I'm just reading that out loud, but let me explain exactly what it means when we look at this first example, part A. So square root of 36. It's like, well, what is the square root of 36? It's 6. And the square root of y to the 6th, what multiplies by itself twice to give me y to the 6th, and that would be y to the 3rd. But what I have to do is I actually have to put that y to the 3rd in absolute values. So the only time you have to do this is if you've got an even index, an even power, and this ends up being odd. Reason being is we have to assure that this is going to be positive. Okay, so it says right here, we have to ensure that the answer is non-negative. Because y cubed could end up being negative if y was negative. So we need to ensure that this is absolutely going to come out positive. So the reason we do this is because y could be negative. Okay, so throw the absolute value only in this very specific circumstance. Okay, right here. 4th root. Okay, so the 4th root of 16. What multiplies by itself 4 times to give me 16? That would be 2. 2 times 2 times 2 times 2. And then when I take the 4th root of something to the 12th power, remember that trick, I just divide 12 by 4, and my new power is 3. Since I ended up with an odd power, I have to throw that in absolute values. We don't know if x is positive, negative, whatever. If this is negative and I cube it, it comes out negative. So I have to guarantee that my answer is going to be non-negative. All right, so a tricky little situation there. See if we can wrap our heads around that. Okay, last little bit that we've got here, approximating radicals with a calculator. So I'll show you exactly how our calculators work to do this. So we've got this formula, surface area of a sphere, and it is this formula right here. V is the volume, that's this V right here. Determine the surface area of a sphere with a volume of 200 cubic inches. So we're plugging in 200 for V, and we're just going to simplify it up as much as we can. So we're going to take this formula, S equals the cube root of 36 pi, and then V squared. I'm going to plug in 200 squared. Okay, so there's not much that we need to do beyond that point for this first part. I'm just going to show you what happens when we plug it into our calculator. We're going to get a decimal approximation. That's okay, because the section said we're approximating radicals with a calculator. It's not anything that'll come out nice and even like the other ones did. Okay, so plug in. We've got the cube root. So let me show you where this button is. See where the square root button is right here? We've got, oh, let me make sure that's on the screen. Here we go. So you've got x squared. Oops. X squared, then there's a square root button. Okay, video keeps cutting me off. I'm sorry. I'm going to try to put this back together. So x squared, we've got this square root right here. And then here we have this little caret key. You hit control and then hit that button. And it gives you an open box where you can put in any index that you want. So we're going to put in the 3. And then move over here and then type in 36 times. Down here next to the H, there's this button that has a pi in it. Push that button. Then you select the pi. And then times 200. Whoops, that was plus, not times. Here. Times 200 squared. Okay, so that's what we've got. So when you hit enter, it'll give you an approximation. Okay, so our approximation is 165 and then 0.388. Okay, and then surface area is going to be in inches squared. Volume is given in inches cubed, but surface area is always squared units, centimeters squared, inches squared, whatever. Okay, oh, and you can see it right here, actually, square inches. So now this time we're given the surface area, and we want to solve for the volume. So we're kind of working backwards from normal. So now we're going to plug in 214.5 for S, and then set it equal to this formula that we have right here. Cube root of 36 pi v squared. So this is actually kind of a little bit of practice with what it'll be like to solve these equations. So we're trying to get v by itself. So whatever we need to do to get that v by itself. So you've got a big cube root. The only way to undo a cube root is by raising something to the third power. Okay, so if you do it to the right-hand side, you've got to do it to the left-hand side. So this whole section is about calculators. So let me show you this here. So we're going to take 214.5 and raise it to the third power. So hit this little caret key next to the x squared button, 2 over from the 4, and you can enter in the third power. Oops, and that gives you a big number. That's scientific notation. It tells you that you move over 6 decimal places. So we get, I have a more accurate answer here. We get this 0.625. We want to make sure we keep this as accurate as possible. Equals, so now we've canceled out the cube root and the cube. We just have 36 pi times v squared. The next thing we're going to do to get the v by itself is divide both sides by 36 pi. Okay, so now back to the calculator. If you just hit divide, then it automatically plugs in this answer. And then in parentheses, put your 36 pi, because otherwise the order of operations will take over and it'll divide by 36, but then it'll multiply by pi. Okay, so we get this nice answer right here. Okay, so let's carry on. So 87,262.9 equals v squared. Last thing we need to do to get the v by itself is take the square root. So take the square root of both sides. I'm going to do this on my calculator. So hit the square root button, control, and then the x squared key. And then there's this answer key. If you can see, you can barely see it on here. Above the negative, it says answer. So hit control and then hit that negative sign. And what it does is it plugs in the last answer. Then you don't have to type it in. Okay, hit enter. And we get, for the volume, 295.403. And that is in cubic inches. All right, so just a little calculator work there, making sure you know how to do cube roots and square things and cube things. All right, so the next thing we're going to be doing, we're going to keep on simplifying radicals, and we're going to be doing some operations. You can see what we have down here. We're going to be adding, subtracting, multiplying, and dividing these radical expressions. All right, so you can look forward to that coming up next.